Hello and welcome to Advanced Engineering Mathematics. My name is Nathaniel Posesorsky, tutor at Nimbus Tutoring, and today we are going to be looking at Laplace transforms, or linearity to be exact. So what is linearity? Let's get started with some theory. So linearity states that the Laplace of a times a function f of t plus b times a function g of t, a and b being constants, and that's equal to a times the Laplace of f of t plus b times the Laplace of g of t. So what this states is that when we are calculating Laplace, a and b over here are constants, and they are not going to affect the Laplace. We're going to take them out and then multiply our Laplace answer by the constants at the end. So let's look at an example to better understand this really. So over here, a great thing to do when you're starting any problem is to state the theory like I did over here above. So the Laplace of a times the function f of t again, plus b times the function g of t is equal to a, the constant, times the function, the Laplace of f of t, plus b times the function Laplace of g of t. So let's look at an example. They give us a function f of t is equal to 6t plus 4. And they tell us find the Laplace. So the first step is always to take what we have, in this case it's the function, and to plug it into the theory. So over here, what constants do we have? Well, we have our 6 over here and we have our 4 over here. So we could rewrite all of this as 6 times the Laplace of t plus 4 times the Laplace of 1. And now we're going to look at our table of Laplace transforms. We know from the other video and from this table that the Laplace of 1 is equal to 1 over s. If you want to find out how to prove this, you could look at the previous video. And we also know that the Laplace of t, or t to the n to be precise, is equal to n factorial over s to the n plus 1. N factorial means that if, for example, it's 2 factorial, it's going to be 1 times 2. Or if it's 3 factorial, it's going to be 1 times 2 times 3. Factorial is this little exclamation mark we see over here. So the Laplace of t to the n is n factorial over s to the n plus 1. So in that case, the Laplace of t is going to be 1 factorial over here over s to the 1 plus 1, which is simply 1 over s squared. And the Laplace of t squared, if we were asked to find, well, that would simply be 1 times 2 over t to the 2 plus 1. So it would simply be 2 over t cubed. Now, step 3 is to simply plug in the Laplaces that we know. So 6 times the Laplace of t gives us 6 times 1 over s squared. And plus 4 to the times the Laplace of 1 is equal to plus 4 over 1 over s. So we get 6 times 1 over s squared plus 4 times 1 over s, which gives us a final answer of 6 over s squared plus 4 over s. Let's look at another example to even better understand. Over here we are giving a function f of t is equal to 1 plus e to the t, all of that squared. And they ask us find the Laplace. So step 1 is always to plug it into the theory. But we can't plug it in right away over here since we have a squared. So we are first going to simplify this. We know that if we take all of this and we expand it, we get 1 plus 2 times e to the t plus e to the 2t. Simply by expanding the square. And then if we do the Laplace of all of this, we get Laplace of 1 plus 2 times the Laplace of e to the t plus Laplace of e to the 2t. Again, we are going to look at our table of Laplace transforms. Over here, rule 1 states that the Laplace of 1 is 1 over s, as I wrote over here. And we know from rule 2 that the Laplace of e to the at is equal to 1 over s minus a. So if we're asked to find the Laplace of e to the 2t over here, as in the question, it is simply going to be 1 over s minus 2, since a is now equal to 2. And the Laplace of e to the t is simply 1 over s minus 1. Now finally, step 3 is to plug in our Laplace answers back into our original equation in step 1. So the Laplace of 1 plus 2 Laplace of e to the t plus Laplace of e to the 2t is equal to 1 over s, as we found over here, plus 2 times the Laplace of e to the t, as we found over here, plus Laplace of e to the 2t, which is 1 over s minus 2, as we found over there. And that gives us a final answer of 1 over s plus 2 over s minus 1 plus 1 over s minus 2. So I hope this was helpful in better understanding Laplace linearity. My name is Nathaniel Posesorsky, tutor at Nimbus Tutoring. If this helped, please leave a like and subscribe, and I'll see you in the next video.